Okay, so we wanted to look and see if these two expressions or these two sides of the equation are equal to each other. And so we want to look at both sides and see ultimately, do we get the same value on either side of the equal sign? And so, I know that like I could add 30 plus 45 to get 75. So I know that the left side is equivalent to sine of 75. Well, 75 is not an angle that we know how to draw a reference angle for, like a 30 or a 45 or a 60, but 30 and 45 we do. And so I could evaluate this side very quickly. Sine of 30 plus sine of 45. If you drew your 30-degree angle, so there's your 1, 2, square root of 3 at 30 degrees. You could draw a 45-degree angle. So there's your 45, 45, 90 triangle, 1, 1, root 2. So I could say, sine of 30 is 1 over 2. Sine of 45 is 1 over root 2, rationalizes root 2 over 2. So I have sine of 30 1/2 plus root 2 over 2. They're both common denominators, so I could add them together and get 1 plus root 2 over 2. I could add, I could evaluate that in my calculator and see what its decimal is. But the question is that value equal to this side? And another way of asking that question is, can you quote unquote distribute the sign? Because I could easily see someone saying, just take sine of 30 and then do sine of 45. But we can also evaluate this particular side by using one of our sum and difference formulas. So I'm going to just put our answer over here. Put our answer like maybe over here so I can kind of keep track of what we got for the right side. And I'm going to expand this since I know that to be true. I know that the sine of alpha plus beta can be expanded. So sine of alpha plus beta could be expanded as sine of alpha cosine of beta. In other words, sine of the first angle, cosine of the second angle, plus sine of the second angle, cosine of the first. And so, again, choosing 30 and 45 degrees to be my alpha and my beta. So I could say sine of 30 cosine of 45 degrees plus sine of 45 degrees and cosine of 30. And again, I could use my reference triangles for here for my 30 and my 45. So I know that sine of 30 again is the 1/2. Cosine of 45 is root 2 over 2 plus sine of 45, there's our root 2 over 2. And then cosine of 30, which is root 3 over 2. So then when I go ahead and simplify this, remember when you're multiplying fractions, you may just multiply across the numerators and the denominators. So 1 times root 2 is root 2. 2 times 2 is 4. Plus, and then root 2 times root 3, because those are both square roots, they can be combined as a root 6. 2 times 2 is 4. And again, it already has a common denominator, so I can add this up to be root 6 plus root 2 over 4. And remember our question, or our other side was, well, we had root 2 plus 1 over 2. And so, even if I try to make this, you could put it in your calculator, see if it's an equivalency, but even if you try to say, okay, can we maybe look at this answer here, and what if we made it a common denominator of a 4? Well, that would be achieved by doing like 2 over 2. And so I could say, are these equal to each other? Well, 2 times 2 is 4, 2 times 1 is 2, plus 2 root 2. And so if I have, only 1 root 2 and I've got 2 there, a 2 and a root 6, I have unequal things. So even without putting them into my calculator to get their decimal approximations to further prove that these are not the same, I know that these are not equal to each other. And really the point of this problem is to illustrate and emphasize that you can't distribute that sine function like you might think, if it was just a coefficient, like, 2 times 30, 2 times 45, okay? A sine of the sum, like the sine does not work that way. It's an operation, it's a function that you want to find its value within that set of parentheses. So this is not true, and we get 2 answers. the right side is equal to 1/2 plus root 2 over 2, where the left side is equal to the quantity root 2 plus root 6 over 4.